The binding energy of the electron in hydrogen atom is 13.6 electron volt. What is the energy required to remove the electron from the first excited state of lithium 2 plus? See, in hydrogen we have one proton, that is the nucleus, with one electron. This is the first orbit known as the ground state. To remove the electron from this orbit to infinity, the energy required is 13.6 electron volt, which is called as the binding energy or ionization energy. So ionization energy for hydrogen equal to 13.6 electron volt. Okay, we know energy of the nth orbit is equal to E1 by n square. So delta E is equal to, what is delta E? E1 minus E infinity. So when you put n equal to infinity, this becomes 0. So delta E equal to E1, which is equal to 13.6 for hydrogen. Now you take the case of lithium. In the case of lithium, the atomic number is 3. So there are 3 protons, 4 neutrons in the nucleus, and there are 3 electrons. 2 will be in the first orbit, 1 will be in the second orbit. Now we are asked to consider lithium double plus. That means 2 electrons are removed. So with only 1 electron, this lithium ion will resemble hydrogen. Lithium ion will resemble hydrogen. Now this goes to the excited state, first excited state. That means n equal to 2. So what is the initial energy of that orbit? It will become Z squared E1 by 2 square. Using hydrogen formula. For hydrogen, Z equal to 1. Therefore, we get En as E1 by n square. When you put n equal to 1, you get E1. Now, this is another atom with Z equal to 3. So, we write general formula. Initial energy is Z squared E1 by 2 square. From here, it goes to infinity because we want to ionize. So, what is E infinity? Equal to 0. So, the ionization energy for doubly ionized lithium becomes delta E equal to E infinity minus E1. And when you write E1, E1 is minus 13.6 electron volt. This is, when you express ionization energy, we have to give the sign as positive. When you express binding energy, you must give the sign as negative. So when you substitute here, the ionization energy becomes 0 minus 9 into minus 13.6 divided by 4. Z square is 9. E1 is minus 13.6. 2 square because it is in the earlier in the second orbit. So this gives you minus minus becomes plus, and this gives you 30.6 electron volt, third answer. So this is the energy required to remove the electron from the first excited state of lithium to infinity.